The drippy dilemma. Imagine a world where every pump leaks. Sounds like a disaster, right? Leaks might seem like a small nuisance, but in reality, they can cause huge problems, from slippery floors to equipment damage and even environmental hazards. Pumps are everywhere, quietly working behind the scenes. They move liquids in countless places, from the water flowing out of your kitchen faucet to the fuel you pump at gas stations and even in massive factories. At the heart of every pump is a spinning shaft, connecting the powerful motor to the impeller that pushes the liquid forward. But here's the tricky part. That spinning shaft needs to move freely, yet the pump must stay sealed tight. How do you let the shaft spin at high speeds, sometimes thousands of times per minute, without letting precious liquid escape? It's a real engineering puzzle. If there's just a hole where the shaft enters, liquid will gush out uncontrollably. This isn't just messy and wasteful. It can be dangerous, leading to costly spills, equipment failure, and even safety hazards for workers. That's where seals come in. Seals are specially designed barriers that fit snugly around the spinning shaft, right where it enters the pump. They keep the liquid inside, prevent leaks, and block out dirt and contaminants that could damage the machinery. Without a reliable seal, pumps would constantly leak, wasting valuable product, creating hazardous work environments, and driving up maintenance costs. Even a small leak can add up to big losses over time. So the humble seal is truly an unsung hero of the industrial world, working silently to keep pumps running smoothly, safely, and efficiently every single day. For years, pumps used gland packing, braided fibers stuffed around the shaft and compressed to form a seal. But gland packing always leaks a little, since the friction needs lubrication and cooling. This means puddles, wasted product, and constant maintenance. Enter the mechanical seal, two ultra-flat faces, one spinning, one stationary, pressed together by a spring. This high-tech solution is nearly leak-free, lasts longer, and needs less adjustment. Mechanical seals don't rely on product leakage for lubrication, so they're cleaner and safer. Less waste, lower costs, and a safer workplace. It's a leap in efficiency and reliability. Science rules. So, what's inside a mechanical seal? At its core are two super flat rings, one fixed to the pump housing, one spinning with the shaft. A spring pushes these faces together, keeping them in contact even with shaft movement. Secondary seals, like O-rings, block other leak paths between the faces and the pump or shaft. All these parts fit into a compact assembly. The result, a device that contains high-pressure liquids while letting the shaft spin freely. It's precision engineering at its best. Mechanical seals keep liquids where they belong, inside the pump. Here's the magic. How do two solid faces, pressed tightly together inside a powerful machine, avoid grinding each other down and failing almost immediately? It seems impossible, but the answer lies in a fascinating bit of engineering. When the pump runs, a microscopic film of liquid forms between the faces, thinner than a human hair, almost invisible to the naked eye. This film is absolutely crucial to the seal's function. This ultra-thin film acts as a lubricant, dramatically reducing friction and heat. Without it, the faces would quickly wear out, leading to leaks and costly breakdowns. The film keeps the surfaces gliding smoothly, almost as if they're floating. At the same time, the film forms a barrier, sealing the process fluid inside. Only a tiny amount of liquid escapes, and that's released as a harmless vapor, barely noticeable, but essential for pressure balance. The secret to this balance is the combination of a strong spring and the pressure of the fluid itself. The spring and fluid push the faces together, ensuring a tight seal, while the fluid film gently pushes them apart, preventing direct contact. The result is a perfect equilibrium, no direct contact, almost no leakage, and a seal that can last for years, even in the harshest industrial environments. It's a tiny, invisible dance of forces, happening every second, right at the heart of the machinery. And that's how mechanical seals quietly keep our industries running smoothly, protecting equipment, saving energy, and preventing leaks, one microscopic film at a time. There are many types of mechanical seals for different jobs. Pusher seals use a spring and O-ring to handle shaft movement, great for general use. Non-pusher metal bellows seals use a flexible metal bellows, perfect for sticky or extreme fluids. For hazardous or abrasive liquids, double seals use two seals with a pressurized barrier fluid for extra safety. Cartridge seals come pre-assembled, making installation easy and reducing errors. Each type is chosen based on the liquid, temperature, pressure, and pump speed. The right seal means safer, more reliable pumping. Mechanical seals are tailored for every challenge. Mechanical seals are the unsung heroes working tirelessly behind the scenes in countless industries. You'll find them everywhere, from the bustling dairies that supply our milk and cheese to the breweries crafting our favorite drinks. These seals are essential components in the pumps and machinery that keep these facilities running smoothly, ensuring that every process is safe and efficient. Their reach extends even further, playing a vital role in water treatment plants that provide us with clean, safe water, and in chemical factories where they help manage dangerous substances. Without reliable seals, these industries simply couldn't function safely. Mechanical seals keep our food uncontaminated, our water pure, and hazardous chemicals securely contained. Their reliability is crucial, as a single failure can lead to costly downtime or even environmental hazards. Many of these seals are designed to operate for years on end, running continuously without interruption. Their durability is a testament to modern engineering. But even the best seals have a weakness. The most common cause of seal failure is running the pump dry, when there's no liquid to lubricate and cool the seal. Even a brief moment without fluid can cause the seal faces to overheat and become damaged beyond repair, leading to leaks and equipment breakdowns. That's why it's essential to always fill the pump with liquid before starting it up. Priming the pump ensures the seal is protected from the very beginning. Carefully following installation instructions is just as important. Cartridge seals, which come pre-assembled, make installation easier and reduce the risk of errors. However, proper pump alignment and regular maintenance are key to maximizing seal life. Misalignment or neglect can shorten a seal's lifespan dramatically. Mechanical seals have replaced old, leaky methods like rope packing, bringing cleaner, more efficient technology to modern industry. They may be small, but their impact is enormous, making much of our daily life possible. By understanding how seals work and taking steps to care for them, we help keep our industries running safely and efficiently. Well-maintained seals mean fewer breakdowns, less waste, and more productivity across the board. So the next time you turn on a tap or enjoy a cold drink, remember the unseen hero inside the pump, the mechanical seal, quietly making modern life possible.